Hello and welcome to Differential Discussions. I'm Melissa,
And I'm Dave.
and today we have another guest series, and we're going to talk about working in research with Dr. Kelly Mackless. Welcome, Kelly.
Thank you so much for having me. I'm very excited to be here.
Thanks, Kelly.
Yeah, so just a little background for everybody. I've already told Kelly this, so I'm going to fangirl a little bit to the audience. I'm really excited to have Kelly on. Like I said, to Kelly, I've been following her on Twitter since right before the pandemic. And then during the pandemic, she started the Blood and Bone lecture series, which brought researchers together to share their research and talk about science on Zoom, or she would post the recording on YouTube afterwards. And we got to just basically have a community during the pandemic, which was absolutely amazing. So I've been fangirling because it's awesome to actually meet her in person, well, on Zoom in person and have her with us to talk about her career. So Kelly, can you tell us about your career? Let's start in school. What did you go for your undergrad in? How did you find pathology?
Okay. School. I honestly have always liked science. I think just because I was curious about the body, like kind of in a gross way. Like I love dissecting things. I was always kind of better. Like I really liked reading, but I also felt like I was always like maybe missing. Like I'm like, I like reading, but it feels a little too deep for me. So I'm like, I love math. This makes sense. But also when you started mixing math with words, I was like, ooh, like physics, no, not into this. Um, Science was just like made sense. Like I'm like, the world makes sense through science. This is it. Loved biology, but then biology started feeling maybe like at least like in high school, I was like, it like got to a point where I'm like, maybe this feels a little superficial to me. Like I need to get a little bit deeper than this. So it like kind of got me around chemistry and like biochemistry. And that's where I got to in undergrad because I'm like, this feels like the core. And then I know like physics people are like, no, it's physics. And then math people is like, no, everything's math. But I guess that's like where my brain settled. And it kind of settled on cell biology. And that's where it stayed. Genetics doesn't make sense to me. Like cell is like the unit that I want to like stay at. Like the cell is like the thing that my brain really understands and revolves around. So, and I had some great teachers in high school. I think there's probably a point in everyone's life. Sometimes it's elementary school, sometimes it's high school, sometimes it's undergrad, where there's some teacher that like sees you for who you are and says, you can do this. Like, actually, I wanted to be a doctor. And my teacher was like, Kelly, you don't like people. You can't be a doctor. And I was like, shit, I don't like people. You're right. And that's why I was like, but I love studying this. I'll be a research scientist. It's like you have that realization. I mean, I do like people, but like maybe, and maybe I like them too much, right? So the thought of dealing, like, I'm so interested in all this medical stuff, but the thought of having to like be with sick people and tell them, and it was like too much for me. So I'm like, how can I help people? Because I really want to help people and really want to learn this stuff, but not have to have this emotional burden, or as much as kind of how I got to the research path. So then I went to undergrad in University of Delaware. I'm originally from New Jersey, as you can tell from this beautiful accent, and stayed around there for like right near Philadelphia. Went to University of Delaware for undergrad and studied biochemistry. And I did undergraduate research there, where is honestly where I really fell in love with research, where I like thought I was doing stuff, but like as an undergrad, you're just kind of playing around. But that's okay. You just like know what it's like to be in a lab. Um, and then applied to schools and wound up at UNC Chapel Hill for my PhD. And we did like rotations in different labs. And I guess, as it turns out, my first rotation was awful. I thought I was doing so well. It was in pharmacology because that's what I was doing as an undergrad. I was studying GPCRs, and I get in this lab and it's like this really big guy. I'm like, oh, I'm so good. I'm so smart. Cause like, I did really well, got really good grades. And at the end of my rotation, my PI calls me in and he's like, I'm gonna give you like like a minus because it's like pluses and minus. He's basically like, I want to fail you, but I'm not gonna fail you. And I'm like, what? You're gonna fail me? And he's like, yes, you did exactly what I told you to do. And I'm like, yeah, like, okay. And he's like, that's not what you do in grad school. You're supposed to like go on your own and do like other things, like go above and beyond. And I'm just like, no one told me that. Like, I just did exactly what you told me. Like, no one told me I was supposed to do other things. So I'm like fresh out of undergrad. And that was like my first really hard lesson of grad school. So it was rough. And I went to like the advisor person and I told her, and she's like, wow, okay, he's kind of an asshole. But like he's kind of also right. And I'm just like, why didn't anyone tell me this? And I guess, you're very young. And after that, I decided I need to try something completely different. And I found this young PI who was really enthusiastic and like seemed kind of nicer. And she did coagulation. And that's how I ended up in this lab with Alyssa Wahlberg. And it was a much better experience. And it's kind of like the rest is history type thing. Learned many lessons the hard way as someone that goes right um into undergrad. And I guess I learned to love it and do something completely different than what I thought.
So I found it interesting. The first PI that you worked with, and then the second, and then a total juxtaposition in how like you performed and how you felt. That's striking to me. Like a personality difference. Is it fair to say it was a personality
Oh
difference?
yeah, it was very different.
That could just change your experience so much. I mean, like I know that, but it's striking that is such a big difference.
I mean, I always tell people that now too. And it's not just from that experience, it's from like seeing it over and over when people are looking for labs to work in to do their PhD. I mean, I don't think that like if you really have your heart set on working in a certain area, then you should. But I think the most important thing to look for is a fit with your PI because doing a PhD is so hard. Looking for a supportive mentor I think is the most important thing. There are so many questions you can ask scientifically that I think you can usually find something that's scientifically interesting to you in the lab, but you can't change the mentor. So looking for someone that you click with personality wise, who's supportive, looking at their past record of trainees to show that they've been successful and things like that, that is the most important thing.
And so, excuse me, you started doing research into coag. And
Yeah, it was straight coag. I was looking especially at fibrinogen and risk factors for venous thrombosis.
all right, very cool. And then how
Yeah.
did you get into megakaryocytes from there?
Yeah, so it's a bit of a pivot. So we were looking, so venous thrombosis is I mean, it affects a lot of people. And you would see people like really young come in and have like a blood clot in their legs. And just, I mean, I found it's very scary because you just will get it and you have no idea, right? Like why you got, there are a couple like factor V Leiden or a prothrombin mutation, or people say, oh, well, you're on birth control, but like how many people are on birth control, right? And don't get it. So what we were doing was drawing blood from, I would go around and like go to nursing homes or like a lot of different places and draw blood from people who had a venous thrombosis and then do retrospective analysis to see if we can find risk factors. So that was a lot of my work. So we wound up looking at factor VIII levels and fibrinogen and things like that. So I'm there for a little over 4 years, published a couple papers looking at thrombin generation, and get really embedded in the community. Love the community, love coag, go to a bunch of conferences, love Alyssa and the work. So I'm thinking for my postdoc, like, I don't want to do the same exact thing, but I don't want to like completely leave the field. Because I've worked so hard, I've networked, and I like really love these people. So I'm like, what's like kind of similar to coag? I'm like, well, platelets is peripheral. The coag factors sit on platelets. This is how I know platelets. Like, where do the coagulation factors do their thing? Platelets. So I'm at a conference and I meet Joe Italiano, and he shows these beautiful images. He is the person who showed the first image of a megakaryocyte making proplatelets in culture. And he shows this movie and he's like very heavily microscopy. And I'm like, ooh, I want to do that. Because all I've been doing for the past 5 years is mixing clear things in tubes. And I want to show movies because that is very cool. Because I think that's one of the big things that a postdoc is for. It's kind of like filling in the gaps. Like, you want to pick up additional skills, learn additional assays, like complementary. So you like kind of expand things. So also, I guess another thing you have to consider was my partner was going to be applying to grad school, even though I tried to convince him not to. So we were kind of targeting like 2 big cities. We're like, okay, Boston and Philadelphia. So I started looking for kind of platelet centered labs, and that's how I ended up here in Boston. And when I with Joe Italiano at Brigham, and of course, so he sits down and it's like going through the projects, and he's like, oh, we platelets this and then megakaryocytes. And I'm like, tell me more about this cell. And he says, well, that's the cell that makes platelets. And we know like some things about megakaryocytes. They like extend these platelets. And Joe got into studying megakaryocytes because he's a cytoskeleton person. And the way that they extend the proplatelets is through the cytoskeleton. And he worked out a lot of the mechanisms of the cytoskeleton. And he says, one of the things that we don't know, we actually have no idea what triggers the megakaryocyte to begin making proplatelets. And I was like, no. And he's like, no idea. And I was like, cool, I'm going to figure that out. And he's like, okay. So from like, I like still have the diagram, and he just like writes like a big question mark. And I was like, I like took it and I was like, this is my project. And he's like, sure. So like literally still, we have no idea what triggers that, but that's what I've been writing grants on. And I would say I've discovered modulators and like ways like that that can make it go up and down during inflammation and things like that. But that's still the holy grail of our field. What kind of triggers that process? We're still working on it. But I think what drew me in, like, people have been working on platelets for so long. They're in our blood. We can take them out of the body. People have been working on megakaryocytes for so much shorter. It was 1994 when we discovered TPO. So we've only been culturing, I don't know, it's like going to be a lot, like, we've only been culturing them for 5 years, but 1994 is a long time ago now, which I don't want to admit. How intriguing megakaryocytes are and how little we know about them, I immediately was just like, buy platelets. I'm working on these cells, like from the time I got in the lab. So I was just like obsessed with them. They're
Yeah,
so cool.
They are really cool. I think that's one of the paths we have for our profession. There's like advanced certifications, and I was able to sit for Melissa and I both have this specialty certification, and studying for it, I really dug into platelets a lot more than I normally would have. This is a microscopic element that I see every single day in the job, like tens of thousands of platelets, right? And then just to learn about what's going on in these tiny little machines, these little anucleate machines. So really, really fascinating. But it was interesting to hear you talk about them as separate entities, because I see them as so much related, you know?
Yeah.
But yeah, so 1994, and I'm pivoting, I'm going all over the place.
No, go for
But
it.
that's recent-ish, right? And I think in the grand
It's so
scheme,
recent.
yeah, that's still a blink. Like
Yeah.
that is not that long ago.
We know like nothing about megakaryocytes, and they're so complicated to study because there's really like no cell lines that recapitulate their biology. So we have to study them in primary cells all the time. We're always culturing them like every week. Our technicians deserve medals for always like doing that. So I think it's my job security because I'm always like, these cells suck, don't study them. But it's like, it's really annoying. It's super annoying. And they're polyploid, right? So everyone's like, oh, just knock it out. And the gene, I'm like, you want me to knock out 16 copies of that gene? Great. So it's really hard. But the cool thing is like anything you find out is new and exciting, but it makes it, and even things that are like dogma in most cells, you're like, this may or may not be true in the megakaryocyte. So good luck.
Everything's on the table, right? Like
Everything's on the table,
yeah.
which is so cool, but also so frustrating.
Is that does the broad the scope of it ever feel like daunting, or
Oh my, all the time. It really does.
so you are a
And
normal
like
person, right? Because to me that's
also
like
it's like hard
overwhelming.
like writing grants and stuff if people aren't familiar with megakaryocytes. They're just like, oh, just do this. And I'm just like, how can I get across to you that I can't do that, or that's really, really hard. So it can be really difficult at times. Like I can't do a screen, I can't do this, there are no markers of this. um it can be really frustrating, but I think that, I don't know, maybe people are beginning to appreciate it. I had to kind of cross over a bit into the hematopoiesis world as kind of a strategy to begin to communicate with those people a bit. And I think it was a good strategy for my career, at least, to begin to talk. And I think that's been helpful.
So, Kelly, can you tell us your job as a researcher? What is your job title right now?
Assistant professor.
Okay. And so what does your job entail?
Well, so I can tell you like what it entails, and then I can like tell you what I actually do. So yeah. So I am basically in charge of my own research lab. So what that means is, at where I work at Boston Children's Hospital and Harvard Medical School, we do not have salary coverage. So sometimes at some schools, you'll have some of your salary paid. That depends. But I'm 100% responsible for my salary, the salary of my trainees, and everything that we buy in the lab. So I have to write grants for that money. Unless maybe one of my postdocs or trainees gets like a grant, but everything in the lab is covered by grant money. So really my main responsibility is funding the lab. So I write grants to the NIH. That's the main source of income. Also different foundations, because we're a hematology lab. We can write to American Society of Hematology, or ASH, American Heart Association. Those are two of the big ones. We don't really do cancer. We're mostly benign hematology. So those are two main sources of funding. I just submitted an HHMI fellowship, so we'll see. So you get creative, you do what you have to do. So that's kind of at the top of the list. The next thing is writing papers. That's how you get grants. So That's like when I come in, I'm like, are there papers to write up, things like that. But then I'm basically a manager, right? So I manage the people in our group. Where we mostly have postdocs and technicians. We don't really have a lot of graduate students because the graduate students that we choose from are at Harvard. So let's say there's like 100 graduate students, and then there's like 2,000 labs that is associated with. So there's not really that many, which is a shame. I have one coming to interview this week, so fingers crossed. I would love to have more graduate students. So I guess in a normal lab, it's a mix of postdocs, graduate students, and technicians. So my job is to manage those people, to mentor those people, to talk about their science, to talk about life, to plan their projects, to plan their experiments, to kind of help them with anything they need. It's really, really difficult, but it's the best part. It's really fun. I'm here a lot. My door is literally always open. People usually just walk in and sit down and say like, oh my God, look at this data, or like, oh my God, this didn't work. And then we just talk. I also have like standing meetings with them every week, just so I'm sure that I can touch base with them. So those are the most important parts of my job. Also, just like so much administration stuff, making sure that everything's on task. So I'm also, I guess some people have administrators. Maybe one day I'll like have money and stuff to hire someone, but like make sure there's like a lot of paperwork that goes with like having an animal colony, keeping things intact. We have to draw blood to get platelets from humans. Like there's so much paperwork that goes into everything, so I have to keep that safe. I'm like planning lab outings. Like if you think about like everything that comes with managing a group of people, just little things you don't think of, keeping all that stuff in order. Also just like having meetings to keep, like we have collaboration, so I don't do all the work myself. If I'm doing a technique that we don't have, instead of learning it, I'll collaborate with another lab. So I'm also constantly having meetings with other people, or saying, ooh, I don't know the answer to this, let me have a meeting with someone else. So I'm having meetings with collaborators, having meetings with other people, things like that. So that is basically my job as a, I guess, PI. In reality, I feel like I just answer emails all the time. That's what I do. My job is to come in and answer emails, and then I walk through the lab and try to procrastinate by talking to everyone. But my favorite part of the job is when I actually get to sit down and talk science with people. It goes a lot from like you're doing science, you're a postdoc, you're doing science, doing science, doing science, doing science, and you have one or two projects. And now I'm managing the lab and I'm like overseeing people doing science.
Yeah, you make the machine keep running, right?
Exactly. And I miss the doing science part.
Yeah.
So the best time is when I can actually like get my hands in the science. And sometimes that's when I write grants, actually, because that's when I see the nitty-gritty of it and I can really like get into the project. But it becomes, now I'm overseeing 10 projects, so you really can't get into the details as much.
And I'm glad you described that, because I think a lot of people, when they think I'm going to get into research, they think I'm going to go in, I'm going to do this one research project, and eureka, I'm going to discover whatever it is I was researching. And I think a lot of people don't have the actual idea of what research is, which is what you were just describing.
Yeah, I mean, as a PhD student, you like basically start with one project, right? And then as a postdoc, most postdocs basically have 3 projects, right? And you kind of build up. And as a PI, you're juggling a lot, and you don't get to really get into it as much. And I haven't been at the bench doing science for probably like 2 years now, and it's sad. But if I walked in and picked up a pipette, I think everyone would like jump and tear it out of my hands. I'm gonna be honest. They'd probably scream. Don't let her near it.
I was about to say, I was going to ask, that's either they love you and they want you to spend your time, or they don't want you to mess something.
No, they love me and they don't want me to mess up my own science.
It's too funny.
Or they think I like had a psychotic break.
Are you feeling okay?
Yeah, what's wrong with Kelly? Get her out of here.
Too funny. Yeah, I think there's definitely it's like anything when you don't have like direct experience. You might have like a sexy version of what something might be,
Yeah.
and then the reality is often some kind of amalgamation of
Yeah.
different.
It's really exciting. I mean, it takes a transition, right? It's like hard. And then the hardest thing is now, and kind of just recently, because technology moves so fast, right? So I'm at the point now where the assays and experiments that we're doing in lab, I've never done hands-on. And I find that really hard because I like to know, like that I've done it and I can see it in my head. So I will walk in and like watch it be done. But like the longest time I'm like, no, like, have you tried this to optimize it? And I can't say that anymore because I haven't done these experiments because technology moves fast and now the people in our lab are so good that they're optimizing things in different ways. And I'm just like, there comes a point where you just have to really trust your people because you haven't done it.
So
And
it
that's
sounds
really
like
hard.
it sounds like you've seen your role just evolve too as
Yeah.
time goes on, right? Like
And a lot of it is really having people that you trust
yeah.
because you have to let go of the control.
Well, that sounds challenging also because your postdocs aren't going to stay forever.
Yeah.
There's a huge, huge like issue, or it can be a huge issue with like loss of knowledge in lab turnover.
Yep. Yep.
We
Mm.
used to have kind of like a lab manager who was with us for, I think she was with us for 6 or 7 years, and it was wonderful. But during COVID, her two daughters had to be homeschooled and she had to leave, and it was just such a sad loss. And it was great because she was consistent, and there's constant turnover in lab, and it can be really short, especially with technicians. A lot of time it's like 2-3 years because a lot of times they're here just trying to gain experience before going to grad school. Postdocs, sometimes it's longer, 4 or 5 years, but still like, so we're trying it now too. We're being very, very careful. We're making like a SOP, like standard operating procedure, like booklet now, and everything's digital. I'm hoping that will help. Children's hospitals mandating it, but we're having it like constantly updated, even though it's true there's nothing that can like take the place of watching and doing it together. But it is always an issue with labs, is like the turnover, because I'm the one who stays and everyone else just like, you don't feel that way. That's the thing. You don't feel like that when you're in the lab. You feel like you're going to be there forever, but because you're like, oh, but it's true, you're not. So memory gets lost.
And so part of your other, I'm missing the other part of your job is then like going to conferences and giving talks about your research. And I'm guessing that's all grant funded as well, or is that out of pocket expenses?
Yeah, that's also funded through my grants. I can't like be wild. Um but if I'm like a reasonable human, that's funded through my grants. But many times if you're invited, they'll pay.
Yeah.
So I also, trying to be a reasonable human, will especially when funds are tight, not go sometimes if I'm not invited to give a talk. And a lot of time conferences are really good with trainee awards. like if you submit an abstract and it's highly rated, they'll fund the trainee to come. So that's good. So that's like a real treat. I will guarantee, well, if I can fund it, I like to guarantee my trainees at least one conference a year, because I think it's really, really great for networking. So we all just went to Italy. It was wonderful. There's a really good conference there, and I had an invited talk, and they all did posters, and it was just like a very good experience. I like going all together to a conference because I think it's like a really good bonding experience. And then if they are like invited to another conference or submit an abstract that gets like invited, then they're free to go to another conference if they can get, you know, the funding for one. That's great, like as many as they want. But I say like I will pay for one for you. And then I try to like not do more than one a month for myself, because it can get really, really crazy, and I want to be here for both my lab group and my own family.
Yeah.
If you want to travel 24/7, you can, but it's just too much. But I love giving talks. Like I think it's such a good way to disseminate your information. I really love science communication, so I like being able to do it in that way. I think it's also really good because like if you have a paper coming out or a grant, it's like such a good way to like prime people to just say like, this is my story, and you're there to ask questions too. And it's a good way to get feedback too. Like when I gave this talk in Italy, we were about to submit a paper, and everyone kind of had a question about the same thing. And I was like, this is going to be the sticking point, like this one thing. So we kind of already knew, and we kind of tweaked the way we wrote about it in the paper.
So I just wanted to back up just a little bit, because you talked about like turnover with your technicians and your postdocs, and what kind of timescales does a typical research project kind of fall into? Like,
Man, that's a good question. And it can be so variable. So they're like, so we have this one project that my postdoc started when she came in, and we have it in, like we submitted it, and we're doing the revisions now for the journal, and I think it could be published in the next couple months. So that will have been like 2.5 years start to finish, so fast, like unheard of fast. And it'll be hopefully, fingers crossed, in a really good journal. That's like, you shouldn't even tell postdocs that, because that's like a myth. And then this other project that she's going to start, I started when I was a postdoc. So we're going to see if she can wrap it up, because I'm like, please, we need this published. I hate this project. And she's going to try to wrap it up after this. So these are like the two projects that she's on. So this is why we give postdocs 3 projects, because there's this one project and the other project. And literally, you have no idea which one your project's going to be when you start it. It's just like, no idea. It's just science. Sometimes they just work, and sometimes they just do not work, and you do not know. So that's why I think it's really, really important to start with multiple projects, like even more than 3, and you kind of like make inroads into all of them and see which ones are just like giving you the middle finger and which ones are just like work, 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 and you gain momentum. You really have a feeling like after 6 months, like that's what's like after 6 months, I always sit down and we're like, this project, like you can see which ones are kind of easier and which ones are not. There's also projects that are like kind of obvious but not exciting. You're like, this is going to get us a publication, but it's not going to be like a Nature paper. But like, we know you'll get a publication. Like you kind of have to, and this one is like high risk, high reward, but let's like do it. And if it doesn't work out, at least we know you have this one, you know, like you kind of have to balance things. And that's my job as a PI, is to lay it out. Like, we're going to do all these things because we want you to have guaranteed publications. the chance of something big, you know, like you kind of have to, and then by like the end of maybe your first year, you have like a couple focus projects. But at the beginning, you kind of have to like pay the science gods because you have no idea which project is going to be what. Hopefully you have one of those like lucky projects that just kind of works and takes off, but that's like a once in a science, like I really think that's like once in a science career type of thing. I had this project that took me 3 years when I was a postdoc, and I swear to God, up until 2.5 years, I had no idea what was going on, like literally no idea. And my PI was just be like, just keep going and collecting data. And I'm like, none of this makes sense. And he's like, you'll get a key piece of data and all of it will make sense. And I had to just blindly collect data and having no idea. It's like I knew there was a puzzle piece that would make it make sense, and I just had to keep going. And it did, but like, wow, that was really hard.
So you needed that piece of data to be able to ask the right question. Is it?
Exactly. It's like it was a signaling pathway, and like the key thing was missing. And I just like kept doing experiments around it. And finally it made sense. But I was so deep into it's like sometimes you have to pull the plug on it, the project, but I was so deep into it. I was like, I spent so much time on this. But every day I was like, should I stop? Should I? And he's like, keep going, keep going. And I was like, okay, I'm trusting you. It was like, oh my God.
What was that moment like when you saw that way through that path?
Oh my God. I was like, I had like been planning his death for like 6 months. And I was like, oh, thank God I don't have to kill Joe. Like, this is like, this is great for both of us because I really needed this paper. Like,
It's too
geez.
funny.
And do you have publication requirements? Like, are you required to publish X amount of papers every year, or how does that work?
No, I mean, I think to get a PhD might be required. It depends on your school and your department. For your postdoc, it's just like you're not going to get a job. I mean, it's really basically like if you want to, I mean, I don't want to say this because, but look, if you want to be competitive to get a independent position, you probably need to have some kind of funding.
Mhm.
So, and if you want to get some kind of funding, you need to have published. That's basically what everything builds on is like, you need to have a grant. And if you want a grant, you need to have a paper. So that's always the hierarchy.
Tough
Um,
environment. So
it makes it really hard to just like enjoy science for science. When you're in a good position and have funding, it's great. When you're not, it's really stressful, and that's the reality. Um, and sometimes when your science is going great and you want to just be able to enjoy it, it's hard because your science going well doesn't always correspond with your funding going well. And that's doesn't make sense. And it has to do with the NIH funding line and factors completely outside of your control. And I think that's the really, really hard part about this job.
so this is kind of I just want a quick policy question. I don't want to go too far
Yeah,
in
yeah.
the weeds here, but do you think the American political system, the American citizens should think about research differently, should invest in those things more? Is that, I know your answer, but
Yeah, I mean, I just don't even think it's in people's minds.
Mhm.
I don't think it's kind of something that people think about. I know like the NIH budget hasn't changed in like, I don't know. I don't know how many years. I know since I've been doing research, I think since probably like Joe's been doing research. So it's become almost unsustainable to do to run a lab with what we call like one R01, which is like one. The pay line is almost 10%. So it's almost like winning the lottery to get one grant, and now you have to get two. So what it's making it is like all we do is write grants. And So we can't like be creative. So if what researchers are doing is tailoring their research to grants, they're not able to tailor their research to like actual problems. And I think that's kind of become the issue, because we want researchers to do research to solve problems in the real world, not to write research to get it funded. And that's kind of what things are going, because the funding line is so low. So if we funded research more, then it would, you know, put more money into labs so we could actually like solve problems that need to be solving, not just write it to, you know, to reviewers in the NIH, because that's what we're having to do. And use our brains to solve problems, not to get grants. Because that's what we're like, get grant, not like, oh, this actual problem, let's solve this, you know? So it
You're
creates
solving a
this,
money problem. Yeah.
that's
Yeah.
exactly what's right. We're
Yeah.
solving a money problem. And we're here solving the money problem and like trying to like not stress out our postdocs, saying, okay, we're gonna just get the money. You try to solve these other problems. But it creates this like really bad loop and like this disconnect in what we can actually do.
Sorry about the detour. I just thought it might be.
No, I appreciate it. It's unfortunately what I think about a lot.
So you had said that your whole lab is funded by grants. So how does it work for you? Do you get health insurance through your job, or do you have to get that externally?
Yeah, I do get health insurance.
Well, that's good. At least you have that, because
Yes, I
I
pay
was
for it.
thinking when you were saying for it, I was thinking about that.
Yeah, like I, man, I don't even know if I should say this, but like I didn't give myself a raise this year. So technically, I guess I took a pay cut because of inflation. But if, for example, if I were to have taken a raise, that would take money out of my grant, and that money could have been used for experiments. So I chose not to, because it's like one big pot. So that it becomes that, which is, I feel like, is an awful choice, right?
It's a bummer.
Yeah.
Huh. Interesting things that you don't think about with research either. Those
Yeah.
kinds of choices that you have to make.
Yeah. I mean, it's not always like that. Like sometimes
Sure.
you can have, we call it like soft money and hard money. So I'm like all soft money. Some people have some hard money. Sometimes there are ways you can get hard money. So
What is soft versus hard money?
so soft money would be all grant money. Um at a lot of at for example, at some other sometimes institutions where you would teach, you would get some hard money. One of the benefits of not teaching, which I don't have to do, is that, or I guess one of the things, like, so to be on soft money, but a lot of times if you have some hard money, you have to teach. So there's like a give and take, because teaching can take away a lot of time from research as well.
And writing
So,
grants.
you know,
Sorry.
it's pros and cons.
Yeah. Yeah. So how do you feel like your work life balances? Do you feel like you have a lot of or a decent amount of time away from the lab, or do you feel like you're more or less always working?
Well,
One of the things we do like to think about is the work-life balance aspect. And I imagine you're going to be on that extreme end.
okay. So physically, I can leave. I feel like it's very flexible. I can leave anytime. And I feel like COVID really emphasized that. Um, I think I always felt like it was flexible, but that really like brought it out. So, and I think that everyone in lab learned to be more flexible too. I think the hard part is mentally leaving the lab. Um, because I'm have a hard time not thinking about it. That also could just be who I am. So I'm not sure that that's the same for everyone. I think that the nature of research is that there are times that are super intense which would be like grant deadlines, paper deadlines, where everyone's like, okay, these 3 weeks before this deadline are going to be really intense. And they are. And then the time after it can be pretty laid back, and you can just like, lots of times I don't work Fridays, and my daughter is like an early pickup, and we can just go out, hang out, whatever. So I think that in general, it can be a good work-life balance. But I think that there are, like really intense times, and, it's kind of ups and downs. It's not consistent, but it's really nice being your own boss. I can always leave. Like, if someone calls or something like that, like I have the kind of flexibility that a lot of people don't have. I can bring her into the office, or the lab or whatever. She loves it. She sits here. I can now, like with COVID, I can always work at home. So I think the hard part is not physically leaving or things like that. But I think the hard part of like working in research is the fact that you can always open your computer wherever you are and start working on email or stuff like that. So and you know what? That's probably with a lot of jobs. So I think working on like turning off and putting down your computer and stuff like that, I think that's really the hard part. But I think physically it's great. You can really do whatever you want, leave or manage, but you have to be in lab. You have to see what's going on, because seeing the dynamics of the people and stuff like that, you can't manage it virtually. But it's just, it lends itself to your wheels kind of always turning. So you really have to find something, yoga, rock climb, I don't know. You have to find something to get your brain out of it.
Well, and I feel like just listening to you when you were telling your story earlier that you had to work to get here though. Because I imagine when you were a postdoc and when you were a grad student, you didn't have this kind of flexibility.
Yeah, I mean, actually, that's the thing, like actually doing the research also lends itself to long hours. And I think like I'm like so curious. So it's like, also I didn't have a kid then, right? So I'm like, ooh, I want to know the answer. And it's like, oh, well, it's gonna be in 4 hours. So I'm the kind of person that's like, well, I'll just stay here for 4 hours and see it at 9 p.m. because I want to know the answer rather than see it in the morning. Cause I'm like, oh, I'll just like watch Netflix here, like, oh, my partner's at, in class till late because I like legitimately want to know, and we'll watch Netflix here instead of at home. So once you like start getting in that mindset, it's hard to deprogram yourself. So you just kind of are like, still want to know. Ooh, oh, I'll just answer this last email. So you kind of are already have become that person by the time you're a PI, and you're like, oh, what have I made myself? So here I am. But that's okay. We're all works in progress. So trying to find joy in other things.
So just to kind of wrap up, if someone was really interested in being a researcher, and let's say they're an undergrad student, maybe at the end of their undergrad career or towards the end, what piece of advice would you give them to move towards going to grad school and becoming a researcher?
Yeah. Well, first of all, I would say don't be scared. It is a wonderful career. You get to like find out how life works and be at the forefront of these discoveries and be with amazing people. So it's not easy, but like life isn't easy. Nothing is. So I would say to get into a lab as soon as possible. People are really happy to have you in lab, to maybe look at nearby schools and look at labs and see maybe if there are technician positions or ways that could. I started when I was actually I started I think in high school volunteering in the lab. So because you want to see if you enjoy being in a lab. I think you don't know until you get into a lab what it's like. I loved it. I was just like, let me look in that microscope, let me see that. I think you just want to be in a lab and see what you think. I always tell people too, like, don't think about like, can I be a PI? Can I do this? Because you do not know whether you can be a PI. You are not at that stage. And when you have to make that decision whether you can be a PI, you will be a different person. You will have different skills. Like, you just need to think about the next thing. Like, you need to think about, like, could I go to grad school, right? And then you have that experience, and then you think, could I be a postdoc? Because when you make those, when you make those decisions, you will have a new set of skills and all that. So at each step, just keep asking yourself the next question. Don't think about far in advance and all that. Just keep having your experiences, keep asking yourself if you like it. And I really do think that things are changing. My generation, the people around me, were very invested in making academic science more equitable, more inclusive. I see change. So don't be discouraged by what you see now. In fact, please come and help us make that change. We're really interested in that. If everyone leaves, then there's no one here to help us make the change. So I think that it's really promising for the future. We want it to look better. So I think get in a lab as soon as you can. Find someone that works in a lab, use the internet. Yeah, there's no way to know from the outside. So begin your experience if you can.
That's great advice.
That was much more encouraging than I thought, right?
If you love it, right?
Yeah.
And you have to do it. Like, I what I said is true. It's hard, but like, jobs are hard, and if you love it, you'll still love it. So we have to keep going.
Absolutely. Well, Kelly, thank you so much. We really appreciate you spending
Thank
the
you for
time.
having me. This has been so fun.
No, it was a wonderful conversation. Thank you. And to the listeners, thanks for staying tuned. And please find us on social media. Send us a message if you want us to relay a message to Kelly, for example, a question or what have you. Please do. And yeah, like and subscribe and all that good stuff. But thanks so much for your time.
Thanks for listening.
Please like, subscribe, and hit the bell if you'd like notifications whenever we post a new video. And feel free to reach out to us on social media or via email with comments or suggestions about future content. Thanks.